Hi everyone, welcome to the Tutorial Academy, and today we are going to be going through number-based system. Now, a number base refers to the number of unique digits that a number system uses to represent numbers. Our general day counting is done in base 10, which is called decimal, and decimal uses digits from 0 to 9. There are other commonly used number bases such as binary base 2, which uses digits from 0 to 1, octal base 8, which uses digits from 0 to 7, hexadecimal base 16, which uses digits from 0 to 9, and letters from A to F, where A is equal to 10, B is equal to 11, C is equal to 12, D is equal to 13, E is equal to 14, and F is equal to 15. So in this chapter, we're going to be learning four basic things. One, we're going to learn how to convert from one base to base 10. Two, we're going to learn how to convert from one base to another base. Three, we're going to learn how to convert fractions from one base to base 10. And lastly, we're going to learn how to convert decimal fractions to any base. So let's get into it. So let's start with the first one, to convert from one base to base 10. Solution. Here we're going to put in place values starting from 0. So 0, 1, 2, 3, 4. So this 1 times the base raised to the power 4 plus 0 times the base raised to the power 3 plus 1 times the base raised to the power 2 plus 1 times the base raised to the power 1 plus 1 times the base raised to the power 0. Let's solve. 2 raised to the power 4, 16, plus 0 plus 4 plus 2 plus 1. This will give us 23 base 10. So we have converted binary base 2 to base 10 using power expansion. So there's another alternative method. Let's go through the alternative method and check if we still get the same value, 23 base 10. Start with this. 1 times the base, which is 2, will give us what? 2. 2 plus 0 is what? 2. 2 times 2 will give us what? 4. 4 plus 1 is equal to what? 5. 5 times 2 will give us what? 10. 10 plus 1 is equal to what? 11. 11 times 2 will give us what? 22. 22 plus 1 is equal to what? 23 base 10. This is the alternative method. If you don't want to do the previous way, you can also do this way, any one you prefer. Going with the second example, D6, E5, and 16. So let's put the place value starting from 0, 0, 1, 2, 3. We know that D is what? 13. So 13 times 16 raised to the power 3 plus 6 times 16 raised to the power 2 plus E is 14. 14 times 16 raised to the power 1 plus 5 times 16 raised to the power 0. And this will give us 5, 3, 2, 4, 8 plus 1536 plus 224 plus 5, which in total it is 55013 base 10. So we have converted this from base 16 to base 10. You can also try the alternative method and it will give you the same result. Let's go to the second one, converting from one base to another base. The first example is 17 base 10 to base 5. So with this, we're using the method of division. So this is 17 and this is base 5. We're trying to convert it to. 5 divided by 17, it is 3, remainder 2. 5 divided by 3, it cannot go, so it's 0, remainder 3. We're counting upwards. So this is giving us 32 base 5. So 17 base 10 will give us 32 base 5. For the second example, we're converting 7653 base 8 to base 16. In this kind of case, we're going to first convert from base 8 to base 10, then convert from base 10 to base 16. So let's convert 7653 base 8 to base 10, giving its place value 0, 1, 2, 3. The 7 times 8 raised to power 3 plus 6 times 2 raised to power 2, 6, sorry, 6 times 8 raised to power 2 plus 5 times 8 raised to power 1 plus 3 times 8 raised to power 0. And this will give us 3584 plus 384 plus 40 plus 3, and the total is 4011 base 10. So now we have successfully converted from base 8 to base 10. Then we're going to convert from base 10 to base 16. Now let's convert 4011 base 10 to base 16. 4011. 16 divided by 4011, we have 250, remainder 11. 16 divided by 250, we have 15, remainder 10. And 16 divided by 15, it cannot go, so we have 0, remainder 15. We're counting upwards. So we know that 15 is what? F, 10 is A, and 11 is B, base 16. This is giving us FAB base 16. So I successfully converted 7653 base 8 to FAB base 16. Let's go to the next chapter, converting fractions from one base to base 10. The first example, we're converting 34.52 base 8 to base 10. So 34.52 base 8. Now let's put the place values. From this decimal, we have what? Minus 1, minus 2. After the decimal, we have what? 0, 1. So we have 3 times 8 raised to power 1 plus 4 times 8 raised to power 0, which is the point, plus 5 times 8 raised to power minus 1 plus 2 times 8 raised to power minus 2. This will give us 24 plus 4 decimal, 5 over 8 plus 2 over 64, giving us 28, 64. We have 40 plus 2, giving us 28, 42 over 64, which is 28 whole number, 21 over 32 base 10. So we have successfully converted 34.52 base 8 to base 10, which is 28 whole number, 21 over 32. The next example for converting fractions from one base to base 10, we have 0.11 base 2. We're trying to convert it to base 10. So 0.11 base 2. So before the decimal point, we have minus 1, minus 2. And after the decimal point, we have 0. So 0 times 2 raised to power 0, decimal point, plus 1 times 2 raised to power minus 1 plus 1 times 2 raised to power minus 2. Right, this is giving us 0.1 over 2 plus 1 over 4. This is giving us 3 over 4 base 10. So I've successfully converted 0.11 base 2 to base 10, which is giving us 3 over 4. Lastly, let's convert decimal fractions to any base. And we're going to be using the answers from number 3 to convert them back to their original base. So the answer 28 whole number 21 over 32 back to base 8. So we're going to first convert 28 to base 8, which is 28. 8. 8 divided by 28 is 24, which is 3 remainder 4. 8 divided by 3, 0 remainder 3, counting upwards. So this is giving us 34 base 10. So I'm going to convert 21 over 32. First of all, let's put this in decimal points. This will give us 0.65625. So we have 0.65625 times 8. So we're going to be using repeated multiplication to convert this fraction to base 8. So this times 8 will give us 25, which is, it give us 5.25. We're using the values after the decimal points. So 0.25 times 8 will give us 2.00. Since the final digit is 00, we are done. I'm going to take this downward. Then we take this one upward, we take this downward. We are getting what? 52 base 10. 0.52 base 10. So we have 34.52 base 10. Let's work on the last example, which is converting 3 over 4 base 10 to base 2. We're going to use repeated multiplication. So 3 over 4 to decimal will give us 0.75, and 0.75 times 2.50, which is 1.50. Now 1.50 times 2, this will give us 1.00, and this is 00 means that we are done. We're taking this downward, which is giving us 0.11 base 2. We have finally converted 3 over 4 base 10 back to base 2, giving us 0.11 base 2. I hope that this video was educational, and I hope that by the end of this video you learned how to convert from one base to base 10, convert from one base to another base, convert fractions from one base to base 10, and convert decimal fractions to any base. Please don't forget to like, share, and subscribe. Follow us for more updates and more educational items. Thank you.